Yeah, good morning, class. Now I'm going to discuss to you this application of integration, the Centroids. Okay, this is for your reference. If you have some, doubts, you have clarifications with our discussions in the classroom. Now this is for the reason that I'd like to do this recording again. So you have here this problem. You are asked to find the position of the centroid of the area bounded by the curve y is equal to 3x squared. You have the x-axis, and then the ordinates when x is equal to 0 and x is equal to 2. Okay, so if you remember in your mathematics under analytic geometry, then you know that this is a parabola, but with the axis at 0, 0. But if you fail to remember this one, you can actually plot the curve by assigning values. For example, you have x is equal to 0, obviously, from this equation that y is equal to 3x squared. When x is 0, y is equal to 0 as well. When x is equal to 1, substituting 1 squared times 3, you have y is equal to 3. Okay. And then similarly, when you have also x is equal to -1, that's the same case. Okay, y is still equals to 3. And then let's say you have x is equal to 2, as we are going to just use this one, this limits, or should I say this boundary at x is equal to 2. When x is equal to 2, it's either positive or negative, you got y is equal to 2 squared is 4 times 3, you have 12. So if you're going to plot, let's say you have here this 0, you have here x is 1, 2, okay, 2, 3, 1, 2, 3. And then you have here, let's say this is 3, and this is 6, this is 9, and this is, let's say, 12. Okay, when x is 0, I'll use red one. When x is 0, y is 0. It's here. When x is 1, positive and a negative 1, that's the same, y is equal to 3. So you have this one, and then also 1, 2, 3. You have also here. Okay, and then when x is 2, okay, y is 12. Somewhere here. Okay, and then 2 is 1, somewhere here. So it's a parabola actually. Okay, so we can plot the curve as like this. Okay, sorry for my freehand. So this is a curve, and now according to the problem, the area is being bounded by the curve. This is the curve, y is equal to 3x squared, and then you have x-axis. Where's x-axis? This one is x-axis. X is equal to 0. This is x is equal to 0. Here is 0, and then x is equal to 2. This one, x is equal to 2. This is x is equal to 2. Okay. In other words, you are going to compute for this area. This is the boundary. Okay. So when you are going to draw a differential strip, that makes that differential strip, I'm going to put it here. This is dx and this is y. Okay. Now, let us compute x bar using this formula. Okay. You have x bar. Actually, y dx, just to remember. Okay. For you to remember, this is differential area. Okay. Same with this one. So x bar, you have a to b from 0. So the differential strip is traveling from here, going here. Okay. So that becomes from 0 to 2. Okay. So you have 0 and then 2. Okay. X, what is y? This one. 3x squared dx. Okay. And then your area or denominator still 0 to 2. This is y dx. Okay. So you have 3x squared dx. You can integrate, meaning you have, this is actually, this one is 3x cube. Okay, so you can have 3x cube, 3 plus 1 becomes 4, and then you have 4 from 0 to 2. And then this one, you have 3x from, okay, from 2 plus 1 becomes 3, okay, over 3, 0 to 2. This one will cancel out, okay. So x bar, you have this one, okay. I could just, yeah, can separate, isolate 3/4, but it's okay. You have here 3, 4, this is what? 2 to the power 4, okay. 2 to the power of 4, okay. Okay, minus, you have here 0, 0. And then at the bottom, you have here just x cube, 2 cube, okay, minus 0. 2 to the power 4, so that you'll avoid to do calculator. It's just like this one, right? 2 and 2 is 4. This one is 4, so you can cancel out 4 here. Okay, you can cancel out 4. So in other words, since you cancel out 4, x bar is equal to, again, let's go back. If you cancel out 4 here, this is actually 2 times 2, 4 times 2, 8 times 2, 16. Divide 4 is 4, okay? 4 times 3 is 12. So you have here 12, okay, minus 0. And then you have here 2 to the power of 3 is 8. 8. Or we can reduce, divide both sides by what? By 4, and then 4. So you have here 12 divided 4 is 3, 2, or 1.5. Okay. How about y bar? Y bar, what's the formula? 1/2 y squared. So 1/2 y squared from A to B is 0 to 2, right? Y, y squared is 0 to 2. What is y is equal to 3x squared. This is y squared dx. And then here again, 0 to 2, y dx. So you have, we know that y squared, y is equal to 3x squared, right? From here. So we can substitute. We have y bar, we have here 1/2, 0 to 2, y squared. Y squared is 9x to the power 4, right? 3 squared is 9, x squared, and to the power of 2 is x to the power 4. 9x fourth, okay, dx. How about this differential area? Actually, this 0 to 2 y dx is already this one. What's this one? This 2 cube or 2 to the power of 3 or 8, okay? Then just write 8, okay? I'm done with that. Let's make that as simple as we can. So have here y bar, you have here 1/2, or this one, 2 times 8 becomes 16. Okay, how about this one? 9x, 4 becomes 5, all over 5, 0 to 2. Okay, then you have 9x5, this is 2 to the power 5, 2 times 2, 4 times 2, 8 times 2, 16 is 32. Okay, all over 5, and then you have here 16. This one will cancel out, will make it 2. 13 by 16 is 2. Thus you have 9 times 2 is 18, all over 5. Okay, so that would be your centroid along y. Okay, we can check from our calculation. It's not here. 18 divided 5 is 3.6. Okay, it's 18 divided 5 or 3.6. Okay, so I think that's all for centroids. I will just upload again another video for your review for some other topics. Thank you.